This question says, evaluate this limit, give an exact answer, no decimals. So we'll get this limit. Okay, so first thing you do is just plug it on in there. So plug in the zero, plug in the zero, plug in the zero, the zero, the zero. What are we going to get? Cosine of zero is 1. This right here, because cosine of zero would be 1. Plus 7 times 0 is 0, minus 1 over on the bottom is e to the 0, right here, 0, minus 0, minus 1. What's that? Well, that's 0 on the top. What's e to the 0? It's 1. 1 minus 1 is 0 over 0. So 0 over 0 is unclear, and it tells us we can use L'Hopital's. So 0 over 0 tells us we can use L'Hopital's rule when we get 0 over 0 or infinity over infinity. And that means we're going to take the derivative of the top and the bottom separately. And separately being the key word. It's not quotient rule. It's derivative top and bottom separately. And so let's do that. So I'll come up here now. Get rid of this. Come up here and I'm going to do this top separately. Let's put the limit in front there. Limit. This goes to 0. Okay, derivative of the cosine, that's negative. Derivative of all cofunctions is negative. Times, because of the chain rule, derivative of the inside, which is 4. Plus, and then this 2 comes down. 14, x to the 1. And the minus 1 just goes to 0. There's the derivative of the top. How about the bottom? E to the 7x, he's our favorite derivative. He does nothing. But since the inside is not a simple x, chain rule says times 0 to the inside, which is 7, minus, and then this guy is 8x to the 7. This guy is minus 7. Okay. Let's plug in the 0 again. Yeah, put in the 0, put in the 0, put in the 0, put in the 0. What do we get? We get sine of 0, which is 0 times 4 plus 14 times 0 over, this is going to be e to the 0 times 7 minus 8 times 0 to the 7 minus 7. What is that? Well, this is 1 times 7, and this is just 0, minus 7. Do you realize we get 0 over 0 again? So what are we going to do? Lopi again. Sometimes we have to do L'Hopital's rule 2 or 3 times. So let's do it again. So L'Hopital again. So that means I'm going to come down here. I'm going to take the derivative of the top and the bottom separately. Again. So then x goes to 0. Here we go. So I'm going to do the derivative of the top. So do the derivative of this. Whoop. In fact, let's rewrite this. This is minus 4 sine 4x. I just took that 4 in the front with the minus there. So what's the derivative of that? The minus 4 just sits. Our derivative sine is cosine. It's a cosine. Times derivative of the inside function 4. It's a new 4 that just popped out. Plus, and what's the derivative of 14x? Just 14. On the bottom, this let's just stick this 7 in the front. So 7. And then e to the 7x does nothing, and then out pops another 7 from the chain rule. Right? That makes sense? I just put this 7 in the front, put it right there. And then 7 e to the 7x stayed as it was, but then chain rule, drew to the inside, drew 7x, the 7 pops out. And this, oh yeah, let's multiply minus 8 and minus 7. That'd be plus 56x to the 7. Oh, wait, they're not multiplying. What am I doing? That's dumb. Let's try that again. We're just doing this guy. Sorry about that. Minus, and 7 times 8, 56x to the 6, and then this just goes to 0, doesn't it? All right, let's try plugging in the 0 again. 0 there, 0 there, 0 there. What do we get? When we do those zeros again, what we get is, um, oops, that's 4 times 1 times 4. Making sense there? Because this part is a 1, cosine of 0 is 1, plus 14. And then here, e to the 0 is going to be 1. So 7 times 1 times 7 minus, and that's just going to be 0. Plug in a 0 there. Boom. So what does that become? I don't know. Minus 4 times 4 minus 16 plus 14. 7 times 1 times 7. 49 minus 0. It's minus 2. 49. Was that the answer? Yes. So we had to do L'Hopital's rule twice. And so there we go.